Hey everyone, welcome back to the channel. This is Abhishek on the other side. If you haven't subscribed to my channel or if you are new to my channel, do subscribe to my channel and press the bell icon in order to get the latest notification first. So without much further ado, let's start our today's video. So today in this video, we are going to solve this problem XOR queries in a subarray. Now it is a medium level question from Leetcode. The question states that you are given an array ARR of positive integers. You are also given the array queries where queries of I is equals to left of I, comma right of I. For each query I, compute the XOR of elements from left of I to right of I. That is from left of I XOR left of I plus 1 XOR to up to XOR of error of right of I. And we need to return the array answer where our array of I is the answer to the ith query. So over here we are given an array of n integers. So let's consider this example. So over here we are given 4 integers and the elements for this array are 1, 3, 4 and 8. And we are also given 4 queries, right? So you can consider this 0 to be our left of I and this is right of I, and here our I is 0, so this is left of 0 and this is right of 0. So we need to find the XOR of all elements present within this range, that is 0 and 1. So if you XOR 1 and 3, you will get 2. So as you can see over here, when we XOR 1 or 3, we are getting 2. Similarly, if you XOR 0 to 3, that is if you XOR 1 XOR 3 XOR 4, then you would get 14 as our answer. So over here also we can see, if we take this example, so this is our array and here is our queries and this is the array of the XORs according to the ranges. So now let's see how we can solve this problem. So before going into the question, so let's first understand how we can perform XOR of two elements. So let's consider that we have two elements, that is 3 and another one is something like 2. Okay. So in order to perform the XOR of two elements, what you can do, you can at first convert this element, okay, into binary. So if we just convert this 3 into binary, it will be 1 1, right? And if you this 2 into binary, it will be 1 0. Now according to XOR, what it tells that when our both the elements are same, that is so let's say that we have 1 over here and 1 over here, right? Or let's say we have 0 over here or 0 over here. So in such situation we are going to get 0 as the result. But if the elements are opposite, okay, or different, now in such situation, that is 1 0 or 0 1, then we are always going to get 1, okay, and that's how we perform a XOR. So if you want to perform this XOR of this 3 and 2, what you're going to do, as you can see that over here we have 1 and here is 0. So when we have 1 and 0 over here, it will be 1, right? And if we have two same elements, that is two same binary bits, it will be 1 1, right? Over here it will be 0. So on XORing this on performing this XOR operation on 3 and 2, you will get 1 as the answer. So if you convert this binary into decimal, it will be 1. So we'll be getting 1 as the answer. So I hope that you understand how we can perform this XOR of two elements. So now let's get back to the question. So let's consider this example. So over here we have an array ARR which contains elements 1, 3, 4 and 8, and we have 4 queries over here, 0 to 1, 1 to 2, 0 to 3 and 3 to 3, right? So what would be our brute force approach? Now our brute force approach would be that so over here we have a number of queries over here is 4, right? So we'll at first go to the first query. Okay, now in that first query we found that the range lies between 0 to lies between 0 and 1, right? So we'll go to index 0 to element at index 0. So at index 0 we found that 1 is there. So we're gonna have 1, right? And then we're gonna go to index 1, right? So we're gonna XOR it with 3. Now in C++ we can easily perform the XOR operation using this sign over here. Okay, so when you perform the XOR operation you will get, so if you see the XOR this is 3, this is 1, so this will nothing but 2, right? Because this is 0, this will be 0, right? So this will give me, if you convert this into decimal, it will give me 2, right? Similarly similarly then we are going to go to this element, right? Go to the second index. Now in the second index we will find that the range lies between 1 and 2. So we'll go to index 1 over here. That is, we're gonna XOR perform 3 or 4, right? And like this way it will also give me an answer. Then we'll go to and next element. So the next element, the range is between 0 and 3. So we're gonna perform operation like 1 XOR 3 XOR 4, right? By traveling to index 0, 1, 1, 2 and 8, right? Because 3 is also there, index 3, right? So this will also give me an answer, right? Similarly for over here also we're going to perform XOR of 3. There is only one element, so it will be 8. Okay, so that's how we are going to perform the brute force approach. Now the time complexity for this brute force approach, so let's consider the number of elements for this array is something like n. Okay, and the number of elements for this queue is something like k. Okay, so it will be nothing but big of n into k. Now this is gonna be our time complexity. Okay, because we are actually traversing through for because for each query we are traversing through the whole array, right? And hence it is n into k. Now if you think about the space complexity, now since we are not using an extra space over here, it will be nothing but big of 1. Okay, so now let's see the more optimized version for this problem. Problem is quite similar to the prefix sum arrays problem, right? Because as you can see we have an array, right? And here we are given some ranges and we need to sort the elements for this present within these ranges, right? So let's see how we can solve this problem using prefix sum array. Now so let's first take a prefix sum array. Now we know that the size of prefix sum array is always 1 greater than the size of the array. So here the size of the array is 4, right? And hence the size of the prefix sum array will be 5. So 1, 2, 3, 4 and 5, right? So you can consider this to be of 0, index 0, this is 1, this is 2, this is 3 and this is 4. Okay, now now in order to store elements, the formula we are going to use is over here, that is pre of I or AR of I. Now before doing that we need to have initialize this element to 0 right, because it's the extra one. Okay, so we're going to start our I from I equals to 1. Okay, no, so we're going to start our I from I equals to 0, right? That is okay. So at first what we're going to do is that we're going to write it as like pre of 1, right? That is pre of 1 is equals to pre of I. That is pre of I is what? Pre of I is 0. So 0 XOR AR of I. Now AR of I is that is our currently our I is 0. Okay, so So let's consider that our I is nothing but 0. Okay, so currently our I is 0. So AR of I is 1, so it will be 0, 0 or 1 is nothing but 1. Okay, so if you perform here, this is 1, this is 0, right, in binary format, so it will give me 1, right? So here we are going to write 1, right, store 1 over here. Next we are going to move our I to index 1. Now in index 1 we're going to again store like pre of I plus 1, that is pre of 2, right? Now pre of 2 is nothing but pre of 2 is nothing but pre of I, right? Now what's this pre of I? Pre of I is 1, right? Pre of I is 1. Okay, so it will be having 1 XOR ARR of I, that is pre of 1, right? So 1 XOR 3. Now what is our 1 XOR 3? So this is 3, this is 1, so this is gonna be your 2, right? So if you perform XOR operation, it will be 2, right? That is 1 1, it will be 0, and 1 0, it will be 1, right? So it will be 2. Next we are going to again increment our I to index 2. Again we're going to see pre of I plus 1, that is pre of 3, right? Now pre of 3 means this element right over here is equals to pre of I, that is 2 XOR ARR of I, that is 4, right? ARR of 2, right, that is 4. So it will be some now binary of 4 is 100 and that of 2 is 10, right? So it is nothing but this is gonna be my 0, this is gonna be 1. If you have 0 over here, it is 110, right? Now 110 is nothing but 6, right? So it will be 6. Okay, next again we are going to increment this I to 3, right? Now pre of I, right? Pre of I, pre of I plus 1, so at index 4 of pre, we're going to store pre of I. The pre of I is nothing but 6, and year of 3 is nothing but 8. Okay, so 6 or 8. Okay, 6 or 8. Now if you perform, now 8 is binary of 8 is 1 0 0 0. Okay, that of 6 is 1 0 1 1 0 1 1 0. Okay, this is gonna be 0, this is gonna be 1, this is gonna be 1, this is also gonna be 1. Okay, and hence we'll be getting 14. Okay, so that's how we are going to create our prefix sum array. Now let me just delete this. Okay, stuff, it's also, yeah. So now we have deleted this prefix sum array, right? So now we need to find this XOR present within these ranges, right? So in order to find this XOR, we're gonna at first go to this index, right? Now this index is nothing but 0, right? Now we're gonna perform this operation over here in order to find this XOR. This is not sum, okay? This is, you can say XOR. Okay, okay. So we're gonna perform pre of r plus 1 XOR pre of L. Now what is R? Now R is nothing but the upper bound, okay, this bound over here, and L is nothing but the lower bound. Okay, now over here we can see I have also written over here, it is nothing but q of j of I, right? So if you consider this index to be j, okay, represent, here we have considered this to be I, it's going this to be j. Okay, So currently our j is nothing but 0. Okay, now q of j of 1 is represent this element, that is 0 of 1, right? And q of 0 represent this element, right? So that's what it represents. So at first we need to find this, right? So over here, if we go according to this formula, it will be nothing but pre of, okay, r plus 1, right? Now pre of r plus 1. Now what is our r? Now r is 1, right? That is pre of 1 plus 1, that is 2. Okay, there is 2. So at index 2 we have element 2. So if we perform XOR operation with pre of L. Now pre of L is, that is nothing but pre of 0, right? Pre of 0. So pre of 0 is 0, and hence we'd be having 2, right? If you perform 2 or 0, it will be 2. So when in the answer we'll be storing 2. Okay, so let's consider the answer over here. Okay, answer vector. Now answer vector would be storing 2. Now next, again we would be going to the next increment our j to 1, right? Again we'll be performing this operation as p of r plus 1. Now currently our r is 2, right? So p of r plus 1 as p of 3 will be 6. So now why we are actually performing this operation. Now if you see in prefix summary what we have done, so let's say that we want to perform this range. Okay, let's say that we want to find this range. Okay, solve this range. Okay, now we know that this element is nothing but the XOR of this all the three, that is 1 XOR, 3 XOR, 4, right? But we need the XOR of 3 and 4. So if we just remove the XOR of 1, okay, by again XORing it up, right? Okay, because if you XOR two elements, that is if you so it will be 0. Okay, so what does it mean? It means that let's say that you XOR 1, XOR 2, XOR, okay, let's say that you XOR 1, XOR 3, XOR 4, again you XOR it with 1, right? Now when you XOR this 1 with 1, right, it will be resolving to 0. Okay, so you are actually performing a XOR of 0, XOR 3, XOR 4, right? And which exactly we want, right? Because this 0 means nothing, right? So which it doesn't matter which element you XOR it up with 0, it will be that element only, right? And hence we are performing this formula over here, right? Because we are actually removing removing the XOR operation of that element. Okay, so now let's get back to our problem. So over here we are given currently our j is at 1, right? So what we're gonna do, we're gonna perform pre of r plus 1, right? That is pre of r plus 1, where is what? R is our 2 plus 3, right? Pre of 3 is 6. Okay, so we're gonna perform 6 or pre of L, right? Now pre of L is nothing but 1, right? That is okay. So we're gonna perform 6 or 1. So it will be something like this is gonna be our 6, this is gonna be our 1, right? And it will give you 7. Okay, so it would give me 7. Okay, now next again we're going to perform, we're going to increment our j2 by 1, it will be 2, right? So it will be pre of r plus 1, right? That is, now our j is pointing to this element, right? So r is nothing but 3, so if you just 3 plus 1 is 4, right? So it is 14 XOR pre of L, right? Now what is the pre of L? Is pre of 0, so 14 XOR 0. So if you XOR anything with 0, it will be that element only, so it will be 14. right? Next again we're going to increment this element by 1, it will be 3. Okay, now again we're going to perform pre of r plus 1, that is over here, that is the r is our 3, right? 3 plus 1 is 4, that is 14, right? XOR pre of L, right? Now what is our pre of L? Pre of L is nothing but pre of 3, right? So it will be pre of 3 over here, as you can see. So 14 XOR 6, right? So 14 is nothing but 1 over triple 10, okay? And our 6 is 110, okay? So this will be 0 over here. So if we perform this operation, this is gonna be 0, this is gonna be 0, this is gonna be 0, and finally this is gonna be your 1, right? And hence we'll be getting 8. Okay, so that's how we get this answer using prefix sum, or you can say prefix XOR array, something like that. Okay, not sum, because we are performing XOR of the elements, right? Now the time complexity for this algorithm will be nothing but big of n. Okay, n plus k, you can say, yeah, n plus k, because we are actually performing two for loops, right? One at the creation, in time of creation of this prefix array, and then according to this query we are just finding the XOR, right, in the given ranges. So if you consider this length to be k, okay, and this length to be n, then it will be n plus k, and our space complexity will be bigger of n, because we are using we have actually used the prefix array over here, right? So now let's get to the code for this algorithm. So now let's see the code for this algorithm. So at first we are gonna have a prefix sum, right? Prefix XOR array you can consider. So let's create a XOR array with integer as data type, name of prefix XOR, you can consider XOR, and the length for this is size of this is year of size plus 1. Let's consider all the elements to be 0 currently. Now we're going to start from I equals to 0 and we'll go up to arr.size I plus plus. Okay, next we're gonna find it as like prefix XOR of I plus 1 is equals to, right, the formula we have already considered before, is equals to prefix XOR of I XOR arr of I, and that's how we create the prefix XOR array. Now once we have created the prefix array, next what we're gonna do is that we need to get the XOR of the provided ranges, right? So let's create another vector of int of answer. Let's start from I equals to 0 up to queries size I plus plus. Now what we're going to do is that we need to use the formula again. So we're gonna have the answer dot pushback is equals to, so let's consider two integers, that is L, which is nothing but queries of I comma 0, and R is nothing but queries of I comma 1, right? I of 1. So then we're going to use this formula as a prefix XOR of r plus 1 XOR prefix XOR of L. So that's it, I think. So let me just return the answer and let's just run this code. So there is a problem over here. Did you mean prefix XOR? Okay, I have written prefix somewhere. Yes, this will be prefix XOR, right? And then we are going to click on submit. And finally, let me just, yeah, it is accepted, right? So that's all for today. I hope that you like this video. If you like this video, do give a thumbs up to the video, share it with your friends and subscribe to our channel and press the bell icon in order to get the latest notification first. So I'll see you in my next video.